In this video, we look at an example from section 14.7 on how to do a global max-min problem. Okay, and by way of getting this video started, let's recall from Calculus 1 that if you're given y equals a function of x and you're asked to find the local max-mins, what you would do is you would take the derivative of this function. You would set it equal to 0 and you would solve for x. And this value of x is what you would call a critical value. Right? Critical values also occur when the derivative does not exist. But oftentimes the derivative will be 0, you'll have a critical value, and the idea here is that you have some function f of x, and we're concerned with where the function has horizontal tangent lines or slope 0 tangent lines. Okay, so you would take your derivative set equal to 0 to find your critical values. There are two in this little sketch of the function of one variable, and then you would run your second derivative test. Okay, which would be to take the second derivative at your critical value and determine if the answer is positive or negative. Okay, and then we recall that you could go beyond the local max-min question in Calc 1, and then you could ask for the global max-mins. And the global max-mins for a function would be asked if you are given an interval on which your function is defined, right? So the question would be if y equals f of x and x is from the interval a to b, right? What is the maximum value of the function where the domain of x is restricted to be some values between a and b? Okay, so what value of x does the local or global maximum occur? Okay, and the way this is done is by computing step 1 by doing the local max-min problem, which was outlined above, and then step 2 would be to check the endpoints of the interval, right? So figure out what the function value is at the two endpoints, and then compare that, find the function at A, the function at B, and then maybe the function value at the critical values. And then you're going to choose the largest and the smallest. Choose the largest, which would be the global max, and then the smallest of these three values would be the global min. So that's the Calc 1 problem. You just have to have your function defined on some interval, and you need to check the endpoints of the interval also. Okay. Well, that leads us into the Calc 3 question. I'll do the Calc 3 problem over here. Right. So in Calc 3, right, you have z is equal to a function of x and y. And we know that if we're going to do the first step, the local max-min problem, we need to do the equivalent of taking the derivative and setting it equal to 0. Right? And the equivalent of the derivative is the gradient of the function, and you need to solve a system of equations and solve that for x and y. And you will get some value, maybe x naught, y naught. This value is the critical value of the function. Okay. Then you would need to proceed to the second derivative test. Right. And the second derivative test, we know that that comes down to looking at the values of the second derivative and the discriminant, or the determinant of your Hessian matrix, and you care about the positivity, negativity of the fxx and the determinant. Okay? That's part one of a global max-min problem. Then you need to check the equivalent of the endpoints. Okay? And the endpoints probably would be best if we do a sketch here to show what's going on. Okay? What you're being asked to do here is, if you have a function of x and y and z, so maybe you have some function z is equal to f of x and y. Okay? And you're being asked to find the local max, so maybe your function looks like as a spot like that, maybe over here there's a saddle point, okay, and over here maybe the function has a local minimum, right? So your surface can be doing different things at different points, and that would be how you would find the local max and mins using step 1 as shown above. But if your function is then you are restricting the domain D would be the equivalent of the interval for calculus 1. It's some region where x and y is defined. Then maybe there are, and when you look at that part of the function above this region, maybe there are points along the outside of the point on the above this domain. This part here is called the boundary of the region D. And the boundary of the region D is the equivalent of the endpoints of the interval I. Okay? So what we need to do is find a way to test the endpoints or the boundary of the region and see if there are any larger values. Or maybe over here there is a smaller value of the function than what was on the inside of the region. Okay? So that's what we need to do. That is the outline of the global max-min question, okay, and how it compares to calculus 1. In the next video, we'll do an example of illustrating how to do a global max-min question for calculus 3.